Welcome to this presentation explaining the calculations used in the RCPA QAP Key Incident Monitoring and Management Systems Report, or KIMMS as it is more usually known. The frequency and risk calculations will be discussed, and along the way the best uses of the data will be presented. For an introduction to the indicators measured by KIMMS, please see the video KIMMS Introduction. The layout of the results for each of the 5 categories is the same, so only one category will be used as an example. The page is headed by the name of the category, in this case, Pre-Analytical Phase Identification Incidents, or ID for short. This is followed by graphical representation of the frequency and risk data, which come from the table at the bottom of the page. In between, your episodes and your total calculated risk for all incidents is shown, as well as the episodes and risks for all participants. The all episodes and all risk are calculated by adding together all participants' your data for the survey. Calculation of your percentage ID is your count for the incident divided by the total pre-analytical incidents for this category expressed as a percentage. For your percentage EPI, the calculation is the frequency for the incident category divided by your episodes expressed as a percentage. The all calculations are the same, but use the all count and all episodes data. What are the benefits of the frequency calculations? Expressing the frequency as a percentage of episodes takes into account different workloads at different times of the year. These are the values that can be monitored over time for performance by the laboratory. Expressing the data as a percentage within the category helps to pinpoint any of the changes seen in the percentage of episodes. If no changes have been made, the percentage episodes and percentage within the category should be stable and any unexpected changes should be investigated. It may be possible to compare results between laboratories within the same organisation where the collection and interpretation of incidents is the same. There are some pitfalls to look out for when reviewing the frequency data. As intimated, results between laboratories should not be compared, as there are many differences between the way the incidents are interpreted and collected. For example, a laboratory where the levels of hemolysis are automatically flagged and commented on will probably have a very different data to one that does the process manually. Your percentage within a category is influenced by how many indicators are measured within the category. For example, a laboratory that counts all 6 incidents within the collection and transport category could have 300 hemolyzed samples out of a total of 600 incidents, or 50%. Another laboratory that only collects data for hemolysis and has 300 hemolyzed samples would have a your percentage equal to 100%. Finally, the all data can only be used as a guide. As a total of all results received, it can be skewed by the presence or absence of a large laboratory's data. We'll now move on to the risk calculation. Not all KIMMS incidents carry the same amount of risk. Some are riskier than others. The KIMMS Advisory Committee assigned levels of risk, as shown in the table, to each incident based on how easy the event could be detected and the likely harm to the patient if it was missed. This is a process known as Failure Mode Effects Analysis, FMEA, and is widely used in many industries, including health. The values assigned to the harm and detection are multiplied together to give a risk factor. The value for harm was based on a recollection being assigned a value of 4. Incidents that would not lead to a recollection, for example, one that causes a time delay, is assigned a value of 1. An event that may well lead to significant harm to the patient, for example, delayed or wrong medical treatment, is assigned a value of 7, while one that could lead to permanent disability or death, for example, a blood transfusion reaction, is assigned a value of 10. Detection has a similar scale. 1, when the incident will be detected, such as an unlabeled tube. 4, when an incident will probably be detected, such as a mislabeled tube. 7, for unlikely to be detected, for example, identification within the lab, such as an aliquoting error, and 10 for almost impossible to detect, such as wrong sample in tube. The risk factor for each indicator is shown as part of the frequency/risk table. To calculate the risk for each incident, the risk factor is multiplied by the count. This is reported as your risk. The all risk calculation is the same, but uses the total frequency for each indicator, called all count, multiplied by the risk factor and reported as all risk. Your percentage risk shows the proportion each indicator contributes to the total risk of all the incidents from all the categories. Your risk is divided by your total risk and expressed as a percentage. This helps to decide which of the indicators should get priority when assigning resources to problems. The harm a type of incident causes will not change. The only way to remove the risk is to not have an incident, and unfortunately with humans involved, that is virtually impossible. The best way to mitigate the risks is to identify the incident so it can be fixed. Unfortunately, if you identify more, the frequency and your risk will increase. To compare risks between laboratories, you need to know whether any risk for any organisation is because more are being reported or because more mistakes are made. Thus, as it stands now, neither risk nor frequency can be used to compare laboratories. Within your laboratory, if changes are made, an estimate of the effect expected on the KIMMS data should be made. Changes to reduce risk could include changes to process, acquiring new equipment, or extra training of any staff and not just in-house staff. If you have not changed anything, you would expect your risk to remain stable over time. In conclusion, the KIMMS program came into being in the very early days of acknowledgement that pre- and post-analytical errors in pathology pose some of the biggest risks to patient safety. It introduced the concept of risk rather than simple frequency at a time when it was a very novel approach. The KIMMS Advisory Committee is working to update the report to better match the expectations of risk and risk management in today's world. However, KIMMS is only useful if the data can be collected by the laboratories effectively and sustainably. We urge all laboratories who are not currently monitoring this data to start sooner rather than later, and for anyone contemplating a new LIS to ensure it can supply this information. Thank you.